Hi, this is Dr. Thomas here, and in this presentation I want to show you how to find the composition of functions. First things first, you first need to understand how to evaluate a function in order to understand how to find the composition functions. And basically, you're just substituting information into the variable x. What I recommend is that you use parentheses to help guide you when you're evaluating a function. So let's say I gave you the function f of x equals 3x minus 5. And I told you to evaluate the function f at x equals 5, for example. So to evaluate this function at x equals 5, all we're doing is substituting the number 5 for the letter x. So the function is 3x, let me write this in red, (3x minus 5). But instead of putting an x here, we know that it should be a parenthesis here. So anytime you see x, just put a parenthesis and it's going to help you out. And wherever I put that parenthesis, I just replace it with what I'm evaluating the function at. And here I'm evaluating the function at 5. So I'm going to put a 5 inside this parentheses, and I'm going to perform that operation. So since 3 is right next to 5, this 3 times 5, that gives us 15 minus 5, which gives us 10. Alright, let's try another one. Let's say I gave you the function g of x equals x squared minus 3x plus 2. And I say evaluate the function g at -1. So what I really want you to do, if you struggle with this area, is wherever you see an x, just put a parenthesis there so that you know to go back and place -1 inside those parentheses. So wherever there was an x, instead of writing the x, I put a parenthesis. And -1 should go inside. So I'm going to make this blue here. -1 and a -1 here. Now what this is saying is square the -1. So -1 times -1 is +1. And we have a -3 times a -1, which is +3, plus 2. So 1 plus 3 plus 2 is 6. Now this is how you evaluate a function. So if we go to the text, you will see that on this page, number 37, we have f of x equals x squared, g of x equals x minus 1. And they want us to find f of g of x, g of f of x, g of f of x, and g of g of x. Again, f of x equals x squared, and g of x equals x minus 1. First they want us to find f of g of x. So this symbol here is just a notation for the composition. So it is actually not the letter O. It's really like a round circle. Okay? And this means f parenthesis g of x inside that parenthesis. So what we're going to do is evaluate the function f at g of x. So we're going to replace the g of x inside of the function f. So what I'm going to do is attempt to color code g of x, make it the blue function. Okay, so f of g of x. Let's look at the function f. See here, this is what this is. But instead of an x inside the parenthesis here, g of x is inside the parenthesis. So what does that mean? It equals, instead of putting an x here, put g of x in its place. Okay? And what is g of x? G of x is x minus 1. So let's put a parenthesis here first, because I know I need to replace that x with what g of x is equivalent to. And g of x is equal to x minus 1. So what we have is x minus 1 squared. And what is x minus 1 squared? A lot of students make this mistake. They try to square the x and they try to square the 1, but that is not how you would calculate x minus 1 squared. X minus 1 squared is x minus 1 multiplied times itself. So we have a binomial times a binomial, which means we're going to have to FOIL this out. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is another negative x. And negative 1 times negative 1 is a positive 1. Notice the like terms here. Negative x minus x. So we have x squared minus 2x plus 1. So the answer is x squared minus 2x plus 1. Now let's do g of f of x. G of f of x is written this way, and since g came first, we'll actually put g first. G of f of x. And let's color code this. Because g we said was blue, let's make g blue and f of x black. So we have g and we have a parenthesis. Now what goes inside this parenthesis? F of x goes inside the parenthesis. F of x is x squared. So we put x squared inside the parenthesis. Okay, so what is this saying? This is saying, look at the g function now. So instead of an x, we have x squared. So for that g function, wherever you see an x, and you want to, you can go ahead and put a parenthesis for that x minus 1. But just go back and replace an x squared inside that parenthesis. So it was not necessary to use that parenthesis there, but this may help you. This is a strategy to help you not get confused. So it's x squared minus 1. Now notice something. F of g of x is not the same as g of f of x. If they were the same, we would have had the same answer, but we don't. These answers are not the same, so you will not get the same answer in most cases when you do f of g of x and turn around and do g of f of x. Now let's do g of x. So since we have two g's here, we have g parentheses g of x inside. Let's make this new g of x green. Alright, so we have g of x here. Put the g parentheses, what goes inside? G of x again. So x minus 1 goes inside, because g of x equals x minus 1. Now what it's saying, look at the g function, and we're going to replace this x here with x minus 1. So wherever I see an x, put x minus 1 in its place. So you go ahead and put a parenthesis minus 1. This was where the original x was, but we'll put x minus 1 in its place. So what do we have now? We have an x minus 1 minus 1. These are like terms, so we must simplify, and it becomes x minus 2. Let's do one more example. Let's say that f of x equals the cube root of x minus 1, and g of x equals x cubed plus 1. Let's first do f of g of x. Let's make g of x blue again to color code it. We should put x cubed plus 1 inside the parentheses. Okay. Now let's look at the f function. Cube root of x minus 1. Cube root. We got an x, so I'll put a parenthesis instead, minus 1. And where that parenthesis is, I'll put x cubed plus 1, because I'm replacing all of my x's with g of x. Alright, what happens here? Look at the 1 minus 1. The 1 minus 1 cancels. And we're left with the cube root of x cubed. So when you have a root and you have a power and they are the same number, then they basically cancel each other out because they are inverses of each other. And the answer is just whatever this is. So the answer here is just x. Alright, g of f of x. Write down the g first, since it's first. Then what goes inside? F of x goes inside. F of x is the cube root of x minus 1. Then we have to evaluate the function g at the cube root of x minus 1. So we're going to replace all of the x's with the cube root of x minus 1. So this is an x. I'm going to put a parenthesis cube plus 1, because that was where x was. I'm going to replace it with the cube root of x minus 1. Again, we have a root and we have a power, and they are the same thing, so they are inverses of each other. So what we get is just what is under the root, just x minus 1. X minus 1 plus 1, the ones cancel and we just have x. By the way, another tidbit, since we did the compositions both ways and both answers became x, then we know that f and g are inverses of each other. Let's do g of g. Okay, so we have g of x. Write down g of x, and inside of this we have x cubed plus 1. Our function g is x cubed plus 1. So inside of this parenthesis, I'm going to replace the x that was here with x cubed plus 1. So it's x cubed plus 1 cubed plus 1. Now that is not an easy thing to do, because we will have to multiply x cubed plus 1 times x cubed plus 1 times x cubed plus 1 plus 1 because of this plus 1. But we can do it, so let's do it. Okay, so what I'm going to do first is multiply these two binomials together, and we'll multiply the last x cubed plus 1 at the end. So x cubed times x cubed is x to the 6. We know that we add exponents when we're multiplying variables. X cubed times 1, x cubed plus another x cubed plus 1. And of course we have this x cubed plus 1 here plus 1. Let's put like terms together. So that's x to the 6 plus 2x cubed plus 1 times x cubed plus 1 plus 1. Now what you can do here is start stacking this. So what we have is x to the 6 times x cubed, which is x to the 9. Then x to the 6 times plus 1, that's x to the 6. Then we're going to turn around and multiply 2x cubed times x cubed. That's 2x to the 6. So I'm going to stack it under here. And then we have 2x cubed times 1. That's a 2x cubed. Then we have 1 times x cubed, which is x cubed. So I'm stack it there. And 1 times 1, which is 1. And notice that we have this 1 as well. So let me color code that so you won't get confused. So this is a plus 1 out here. We really just need to add another plus 1 here. Okay, so what do we have? We have x to the 9 plus 3x to the 6, since this is understood as a 1x to the 6 here, plus 3x cubed, again that's a 1, plus 2, since 1 plus 1 is 2. So g of x is x to the 9 plus 3x to the 6 plus 3x cubed plus 2. That concludes this presentation on the compositional functions. I believe that this presentation will help you a whole lot.